This is a lesson for section 1.2, even and odd functions for pre-calculus. So this is just a way that we can classify functions, calling them either even, odd, or neither. So we can do this graphically or we can do it algebraically. Looking at the graphs of the functions, our even functions, which this one over here on the left, they have symmetry about the y-axis. So if you could fold the paper along the y-axis and the function lays on top of itself, then the y-axis is acting like the line of reflection, and we say that it has y-axis symmetry. If you want to look at it even further and kind of examine the ordered pairs that you see on there, if you pick a point, so I know on this function, the point 1, 2 is on my function, then the point -1, +2 should also be on the function. So basically, when you negate the x, or when you have the opposite x's, then they have the same y values as each other. And you should be able to pick any point off of that graph, and once you negate the x, you should have the opposite of the y. So looking at this point up here, so this point is 4, 6. So then you should expect -4, 6 to be on your graph, which it is. When we are looking at odd functions, so the odd functions have symmetry with respect to the origin. So that means you could kind of double fold it. I could fold it over the y-axis and then fold it over the x-axis, and then it would lay on top of itself. Or if you can think about it, like if you spin the picture upside down with the origin being like the point of rotation, then it would look exactly the same. And looking at the ordered pairs, if I pick a point, so here's a point here, this point would be the point 2, 1. When you negate the x, it also negates the y, or makes it the opposite. So the opposite x will give you the opposite y. So if 2, 1 is on there, you should expect that -2, -1 is on there. So the opposite x values, oops, that's supposed to be parentheses. So the opposite x has the opposite y's. So looking at the point that you pick, if you take the opposite of the x, then you will have the opposite of the y. So let's look at another point there. So the point, it's hard to see that grid. So I could pick the point 4, 8, which is probably about right here. So since that point is on there, and we're saying that this is an odd function, then the point -4, -8 should be on there, which it is. So that's how you do it graphically. Algebraically, you have this algebraic test for symmetry. So what you're going to do is you're going to substitute -x for all your x's and then simplify the function. If you get the exact same result, then it's going to be an even function. So if the function you get as a result is exactly the same as the original function, then you're going to have an even function. And if it's the exact opposite, it's odd. So that's what this means here. So plugging in -x results in the exact same function as the original. Or plugging in a -x results in the opposite of the original. So that's what that notation means. Here are some examples for you. So graphically looking at these, number one, this one doesn't have symmetry about the y-axis. It doesn't have symmetry about the origin, so we say that this is neither. For number 2, this is our absolute value function. As you can see, this is symmetric about the y-axis. So this line, the y-axis here, that's my line of symmetry. So this is even because it's symmetric about the y-axis. Same thing with this one. My line of symmetry is right down through here. So this is also even because this line of symmetry is through the origin. I'm sorry, the line of symmetry is the y-axis. Okay, and then this one, this is going to be an odd function because I could rotate it and it would look exactly the same. This is also an odd function. And then this one is neither. No symmetry on that one. Then determining algebraically. So this is your algebraic test for symmetry. So what you're going to do is you're going to plug in a negative x for x. And then you're going to simplify and then just examine your result. So my function notation, f of negative x, I'm putting in a negative x for all my x's. Use your parentheses. And then you're going to simplify that. So when you raise a negative to an odd power, it stays negative. So this first term is negative x cubed. And then negative 6 times negative x is going to turn positive 6x. And as you can see, both my signs have flipped. So this is the opposite of the original. So that means this function is odd. And it means that it has symmetry about the origin. And then the second example here, again, I'm just plugging in negative x for all my x's. And I'm going to simplify. Raising a negative to an even power turns it positive. And then this one, you want to make sure you follow your order of operations. I'm going to raise that negative x to the second power. It's going to go positive, but then I'm multiplying it by negative 2. So it turns into negative 2x squared. So this is exactly the same as the original. So if you get the result is exactly the same as the original, then it's even. And then the last example that we did for class was number 3. So again, plugging in negative x for all your x's. And then simplify. Negative x to an even power goes positive. 2 times negative x is going to give me negative 2x. And then my positive 1 is going to retain its sign since it doesn't have a variable with it. And as you can see, we had one sign flip and 2 signs that did not. So this is neither.